Dear students, in this video I will explain very important topic in second year chemistry. State and explain Nernest equation with the help of metallic electrode and a non-metallic electrode. Nernest equation, an equation used to calculate the potential of metal or a non-metal single electrode at any concentration measured with respect to standard hydrogen electrode is called Nernest equation. Suppose for metal electrode, suppose zinc single electrode is taken in a known concentration of ZnSO4 solution and is galvanized with standard hydrogen electrode. Then the single electrode potential of metal zinc is calculated by the following formula. E Mn plus bar m. Here in the metallic electrode, the equilibrium is Mn plus ions gains n electrons to become m. Mn plus ions in aqua solution and m is the metal solid. So therefore this single electrode, the electrode potential, this is the equation to find out the electrode potential of metallic electrode. Nernest equation, E Mn plus bar m, this is a single electrode notation. E means electrode potential is equal to E naught Mn plus bar m, standard electrode potential, minus 0.059 by n number of electrons gained or lost into log m concentration divided by Mn plus ions concentration. Therefore, E Mn plus bar m is equal to E naught Mn plus bar m minus 0.059 by n into log m concentration. M is a solid. The concentration of solids and liquids is always taken as unity, that means 1. Therefore, 1 by Mn plus. So, here m by Mn plus, it is the equilibrium constant. Equilibrium constant Q is equal to the ratio of concentration of products divided by ratio of products and the concentration of reactants. That's why m by Mn plus. Next, particularly for zinc electrode, E Zn2 plus bar Zn is equal to E naught Zn2 plus bar Zn minus 0.059 by 2. For Zn2 plus ions need 2 electrons to become Zn. So therefore the number of electrons gained by Zn2 plus is 2. So therefore n value is 2, then log 1 by Zn2 plus ions concentration. Therefore E Zn2 plus bar Zn, electrode potential for metallic electrode. This is the Nernest equation for zinc electrode. And E naught Zn2 plus bar Zn, if you change this minus into plus, then this denominator becomes numerator. Therefore plus 0.059 by 2 into log Zn2 plus ions concentration. This is the Nernest equation for zinc electrode, metallic electrode. And this one is the Nernest equation for general, any metal electrode. Next, for non-metal single electrodes, suppose chlorine over platinum electrode. Chlorine gas is passed over platinum electrode. This is the non-metal electrode. Is taken in a known concentration of HCl solution and galvanized with standard hydrogen electrode. So any single electrode wants to galvanize it. If you want to make galvanic cell, that single electrode combined with standard hydrogen electrode. The potential of standard hydrogen electrode is 0, so therefore if you want to find any electrode potential for any single electrode, you need SHE. So, with SHE, the scientist found the electrode potential for single electrodes. So, therefore, chlorine electrode is galvanized with. So, that means chlorine electrode is combined with standard hydrogen electrode to form a galvanic cell. So, single electrode potential for non-single electrode is calculated by the following formula. Here the formula. Before going to understand the formula, let me explain this one. M plus Ne minus. That means non-metals always gains electrons. Metals always has the capability to lose electrons. Metals always has the tendency to lose electrons, but non-metals gains electrons. M plus Ne minus. Non-metal is M, then it gains N electrons to become Mn minus. That is the equilibrium. Then for non-metal single electrode, Emn minus N minus bar M is equal to E naught Mn minus bar M minus 0.059 by N into log Mn minus by M. Here the product is Mn minus, the ratio between products and reactants in this equilibrium. Mn minus concentration divided by concentration of M. So, Emn minus bar M, this is the non-metallic single electrode, is equal to E naught Mn minus bar M minus 0.059 by N into log of Mn minus. Here M, concentration of M is taken as 1. Next, particularly this is a general equation for any non-single electrode. If you apply that equation, Nernest equation for chlorine electrode, you can write chlorine electrode Nernest equation like this: E Cl minus bar half Cl2 comma Pt. Pt means platinum. So we are passing the chlorine gas over platinum electrode is equal to E naught Cl minus bar half Cl2 comma Pt minus 0.059 by 1, because 1 Cl minus half Cl2, that means 1 Cl get 1 electron to become Cl minus. So we need how many electrons are transacted in this process? Only 1 electron. 1 electron is gained by the chlorine. So N value is 1 and log of Cl minus and concentration. This is the Nernest equation for chlorine electrode. Then here also I will have another important question. Define EMF, electromotive force, and calculate the EMF of the following galvanic cell. This is the galvanic cell is given Zn plus Cu2 plus gives rise to Zn2 plus Cu, and more importantly standard potentials. Whenever you have E naught, that is standard electrode potentials are given. Let me explain the answer. Here EMF, the voltage developed by any source of electrical energy such as battery is called electromotive force, EMF. And galvanic cell Zn plus Cu2 plus gives rise to Zn2 plus Cu, that is the galvanic cell, and these values also already given. Therefore EMF of this cell equal to E naught RHS minus E naught LHS. RHS means right hand side electrode, and LHS means left hand side electrode. The values substituted here, we get 1.1 volts. And I want to explain another important problem based on this Nernest equation. Let me explain this one. This is very important problem. Calculate the EMF of the cell at 25 degrees C. That cell is given here and the standard electrode potentials also given. Answer. Here the cell reaction is very important. Cr becomes Cr3 plus. Cr becomes Cr3 plus. Cr becomes Cr3 plus. So first we need to write Cr gives rise to Cr3 plus, okay, then Fe2 plus becomes Fe plus Fe2 plus Fe2 plus becomes Fe. This is the equation, skeleton equation. Then we need to balance the equation. How can you balance? Here 3 plus, if you put 2 here, 2 3 is 6 plus. Then right side also put 3 here, then 3 2 is 6 plus. So both charges are balanced. So first we need to balance the charges. Then here 2 CRs are there. That's why we put 2 also in front of 2 chromiums and 3 Fe. This is the balanced equation. Then here N is equal to 6. 3 2 is 6 plus ions. 6 plus ions. So F is how many charges are there? 6. Then it will become only Fe. How many electrons are transaction in this process? 6 electrons. So therefore N is equal to 6. And E naught, first we need to find the standard electrode potential. E naught equal to E right minus E left. So E naught right minus E naught left. So we substitute this value, we get 0.30 volts. Then the answer, E cell equal to electrode potential for that given cell equal to E naught cell minus 0.059 by 6. N value is 6 and log of Cr3 plus whole square. How can you write that one? Because you need to here look at the equilibrium. Take this one is a equilibrium. Right side ions are Cr3 plus and left side Fe2 plus. So Fe is solid and Cr is solid. So the solid's concentration taken as 1. Therefore we neglect that. Cr3 plus whole square divided by Fe2 plus whole cubed. So therefore Cr3 plus whole square by Fe2 plus whole cubed. Therefore E cell equal to 0.30 minus 0.06, 0.059 approximately equal to 0.06 into log of Cr3 plus ions concentration. Cr3 plus ions concentration is also given in the problem. Cr3 plus ions concentration 0.1 capital M and Fe2 plus ions concentration 0.01 capital M. Capital M means molarity. So therefore if you substitute the values, we get 0.30, E naught cell value is also found, minus 0.06 by 6 into log of 0.1 whole square divided by 0.01 whole square. Next one, here how can you calculate this? Let me explain this. First of all 0.1 whole square. So first 0.01 not whole square, it is whole cubed. Sorry, it is whole cubed, 0.01 whole cubed. So 0.01 into 0.1 divided by this value is 0.01 into 0.01 into 0.01. That is the value. We can write this one is 10 power minus 1 and this one is 10 power minus 1 divided by 10 power minus 2 and this one 10 power minus 2 and this one 10 power minus 2. So that is equal to 10 power minus 2 divided by 10 power minus 6. That will become 10 power minus 2 into 10 power 6, that is equal to 10 power 4. Okay, 10 power 4, log 10 power 4. The total value is log 10 power 4. Next one. So like that log 10 power 4 becomes 4 log 10. So therefore E cell equal to 0.30 minus 0.01 into 4 log 10. Then 0.30, 0.01 into 4, 0.04. Log 10 value 1. So therefore we get 0.36 volts. Very important thing is in this total explanation, we need to take this equation. This is very important to find out the electrode potential of the given galvanic cell. Okay, thank you.